Hi everybody. So this question was asked to do from homework 20A, question 22. So basically it says this. So two lightweight electrically neutral conducting balls hang from threads. Choose the diagram. So the diagram down here. And so we have to choose, so they're giving us kind of four different situations. I'll go by them one by one, and we got to choose which one best fits that situation. What should we get? Just a reminder to you that Coulombs Law, remember this is to calculate, so if we have two charges, any charges, it could be a little bit of charge or a lot of bit of charge, could be positive or negative. But basically, so I got two charges here, and how you calculate the electric force is you multiply those two different charges together, and then you divide by the distance between each object's center, and then after you do that, you multiply it by this constant called Coulombs Constant, 9 times 10 to the 9 newtons meters squared over Coulomb squared. So Coulomb gets his own law, constant, and units. Way to go, Coulomb. And so then we got the electric force as well. So there you go. Okay, so that's what we're going to do. Well, all right. So let's look at some of these. So looking at part A, it says both of the balls are touched by a negatively charged rod. So, okay, if they're both negatively charged, they're basically going to repel one another. So that means it's either going to be B or D. However, they repel one another equally, right? To calculate the electric force on this charge, it's, this equation. But to calculate the electric force on this charge, it's also this equation. And basically, it's just kind of confirming Newton's third law. Both are going to feel the same force from each other. So I'm going to go with B. So A is B. I'll just write it over here. All right, moving on to this one. So it says ball 1 is touched by a negatively charged rod. Ball 2 is touched by a positively charged rod. Well, if I got a negative and positive, that's going to cause attraction. So it's either got to be C or E. Those are the ones that are showing me attraction. Once again, they're going to do it equally because it's going to feel equal force. So that's going to be C then right here. So all right. So next up is going to be C. Boop. So both are touched by a negatively charged rod, but ball 2 picks up more charge than ball 1. So this time now, so they're both negatively charged. So it's going to cause repulsion, right? So each one's negatively charged, but one of them is bigger than the other. Well, once again, you might think, oh, all right, now I'm going to go with maybe D because that's going to be bigger. Well, but both charges are used here to calculate that thing. And so, yes, they're both going to be equal again. So it's going to be, again, B. So we'll get that B in there. And then lastly, it says only one ball is touched by a negatively charged rod. Note that parts A through D are independent. These are not actions taken in a sequence. So, yeah, now I read that, right? So it says only ball 1 is touched by a negatively charged rod. Well, this is kind of similar to what we did with that... where was that? Here. It was in charging. I think, yeah, here. So, right, when we brought the negatively charged balloon towards the neutral wall, you induce a charge. The wall gets polarized so that part of it becomes positive, the other part becomes negative. Yeah, and so that's what we're going to see here as well. So, yeah, so only ball 1 is touched. So ball 1 is going to be negative. Let's do, or here, I'll draw it down here. So here we go, draw it like this. Ball 1 is going to be negatively charged. And so this neutrally charged object, though, is going to polarize. Basically, the electrons are going to be repelled by them, leaving positive charges left over here. And by polarizing it, so, okay, now we got essentially mostly negative. So, again, then when we get there, we got positive charges here that are going to be attracted to this thing. And we got negative charges here that are going to be repelled by that same thing. But the thing is that the positive charges are closer in distance to this negative charge. And the Coulombs law depends on distance. So if that's the case, then we're going to get attraction as a result. And they're going to feel equal attraction, so we're going to get C. Yeah, there you go. So you're going to go C. And, oh, sorry, right here. So BC, BC. All right, so yeah, hope that helped. All right, bye.